Great. Good evening once again to everyone. I trust we're doing well. In yesterday's session, that was session 22, you made some very good progress. You took a look at loops. Loops are very important in programming. And you took a look at the for loops. You took a look at while loop, and you also took a look at do while loop. And by the end of the session, I believe everyone in here you made some good progress. All right. In today's session, session 23, we are taking a look at built-in Arduino functions, built-in Arduino functions, and how to create our own functions. Right, built-in Arduino functions and how to create our own functions. But before we go into it, we need to know what at all is functions. When you mention functions, what are we referring to, right? And when you started making some progress, we had been going into the Arduino IDE, writing some code, and you saw some keywords. You saw something like serial that begin. You saw something like digital write. You saw something like digital read. You saw something like analog read. Those keywords, those specific keywords that when we write, the color changes. I believe you also noted map, MAP, right? Map, and we use that when we wanted to change the scale, to change the range of the values of a sensor. So if a sensor is giving us a range of values from 0 to 1023, an analog sensor, it's going to be giving us values from 0 to 1023. And we do not want that particular range, but we want the range to be in terms of 0 to 100. We use the map function, right? We use that map keyword, right? Up until now, you appreciate a little bit. When we mention functions, you appreciate it a little bit, but you do not really know what functions are. Perhaps someone in here, or some of you have done a little bit of searches, but yeah, let's go straight into it. What are functions? What are functions? Sometimes when you are building a system, even without building a system, in our general lives, we want a way to reduce there's a saying that work smart and not really work hard, right? It's you're working hard, but you need to work smart. You need to find ways to make what you're doing smart. And so that's the reason why we use functions. So um functions in programming is, you want to turn an LED on, right? You want to turn multiple LEDs on, right? So you just have to come up with just a structured way, in which you just write a piece of code. You design it, right? You design a piece of code that can be reused, can be used multiple times, that can be reused, right? So you can, for example, if you are building a system, and to write, you do not want to keep repeating. When we went into mechanical design, and then we're doing designs, when we drew some shapes, some sketches, when we're doing sketches, when we drew some shapes, sometimes you don't want to waste time drawing a whole lot of circles, like 20 circles. All you have to do is just copy one and then paste them, right? So that's the idea behind functions. And we also use the mirror tool. So when you draw something on the right, you can mirror it to appear on the left. And in the same way, you can just draw half of what you are designing. You can just draw half of it on the left side, and then you mirror it so that the other side appears, right? So that the right side appears, and then it becomes a full thing, right? So that's the idea behind functions. Functions, just as the word sounds in our ears. When you say the function of something, it means it does a specific work, right? Yeah. And so what we do in programming is, we want to work smart. So if we want to turn an LED on, for so many times. If we want to, if we'll be connecting so many LEDs to the system, we do not want to keep writing a whole lot of code that we're going to write one code for an LED, we're going to write another code for a green LED, we're going to write another code for a blue LED. No, we're not going to do all of those things. But what we do is we just design. It's like a car. You design the chassis, right? The metallic, the skeletal part of the car, and then you can choose to add in some designs as you go forward. So that's it. Functions is just our doing something basic, right? It's just our designing something basic that can be used in many instances by just adding just a little bit of specifics, right? Just a little bit of specifics. Back in high school, or back in a junior high school, or in a primary school, someone you may be writing myself, tell you to write composition, write myself. So you say my name is Kingsley. I come from Takrade. You mention all of these things. So first you say your name, you mention your hometown, and then you mention your age. You mention well, perhaps you can say who your parents are. You can say your best food, your best game, and all of those things, right? So I I can write that, in an exam. If we are a class of about, we have Isaac here, we have Bernard here, we have Michael Poti here, we have Rodi, we have Abdul Salam. So if we are a group of people in a class and we all want to pass, all we have to do is we just have to get one of us who's good at writing myself, and then he puts up the skeletal system of the composition we are trying to write. So we may choose Isaac. Perhaps Isaac may be so brilliant, or Roddy may be so brilliant. He will just write, my name is, right, and then he puts a dash there, and then he write I come from, and then he puts a dash there, and then he says, I am dash years old, right? And then on the next line he says, my best food is dash, my best game is dash, right? So that's it. That's indeed a function, right? So so we get one of our colleagues who is very brilliant. He comes up with a skeletal system of a composition for writing myself, right? So my name is dash, I come from dash, I am dash years old, my best food is dash, my best game is dash, when I grow up I want to be dash in future, right? So he just writes all of those things, and then he puts the dash there. So now, after putting up the skeletal system of the composition, writing myself, he does not put his actual names there. He only says my name is dash, I come from dash, I am dash years old, right? He puts all of those things in there. He puts the dash dash there. He writes everything. He puts the dash dash there, and then he's going to give it to all of us in a class. So when Isaac comes up with it, or if one of us, Rodi, is so brilliant, we rely on Rodi, and then we say, Rodi, please write up the template for us, or the skeletal system of writing a composition myself for us, and then he writes everything, right? And then after he shares it with us, and all of us, we copy the same thing. So we say, my name is dash, I come from dash, I am dash years old, right? My best food is dash, my hometown is, I come from dash, my favorite game is dash, right? That's it. So simple. And then when I copy it, all I have to do is just put my name at the part where it says dash. So it says my name is dash, and then I put my name there. My name is Kingsley Kwesi Mensah. In the same way, if the composition is good, if the template or the function is going to be used by Bernard, Bernard is not going to be writing my name there. He's going to put his name there. So he's going to say, my name is Bernard. And then if Rodi is going to be using the same template or the same function, or the same skeletal system, he also puts his name there. So my name is Dash, and then he writes Rodi Frimpong at the part where it says Dash. So that's it. And then Michael Opoti can also say my name is Dash, and then he puts his full name there, Michael Opoti. Isaac can also put his name there. Felix can also put his name there. So I believe we are getting the concept. A function is just a piece of code that we can reuse, right? We can reuse depending on the specifics. Depending on, we only have to add the specifics. So it's just like my name. It's just like myself. So my name is Dash. I come from Dash. When we give it to a specific person, all he has to do is just put his specifics in there, right? So if we give it to Bernard, he writes his actual name there, his hometown there, and everything is good, right? So we can reuse the template so many times. We can reuse the function so many times. It's the same way. You can create a function for turning LEDs on, right? You can create a function for turning LEDs on, and all you have to do is just put the pin number of that LED there, and then how long you want to turn the LED on, or how long you want to the duration you want to turn the LED on, or the duration you want to turn the LED off, right? And when you do that, you're going to save time. You're going to save time. Imagine if an entire university knows, all of the students in a university are unable to write myself. 500 students, 1,000 students, or 2,000 students. Everyone knows not how to write myself, right? So all they have to do is one brilliant person will just put up a function. One brilliant person will come up with a template. He's going to write, my name is Dash. I come from Dash. I am Dash years old. My favorite food is Dash. My favorite game is Dash. So simple. And then he's going to give it to each student, each individual student. So he's going to give it to 1,000 students, and then now they can customize. They can put their own specifics on the paper, on where at the part where it says Dash. So if we give it to someone called Peter, he's going to say my name is, and then he writes his name there, Peter. So the function has now worked for Peter. And then we'll give it to someone called a different person called a different name, and then he also puts his name there. So one particular single template that we create can be able to serve lots of people. So that's the idea behind functions. So yeah, let's go straight into it. Let's go into Arduino IDE, and let's make some progress. But before we go on into Arduino IDE, give me a thumbs up if you've gotten the idea behind functions. Give me a thumbs up if you've gotten the idea behind functions. It's just when we want to. All right, Isaac, that's great. Bernard, that's great. Abdul Salam, that's great. Michael Opoti, I believe you're also great. Felix, all right, Felix, that's great. Michael Opoti, I believe you're also good. All right, so functions is just when we want to create something that is not so specific. We just create something that is not so specific, and it can be used by multiple people. It can be used in multiple instances. All we have to do is when the time comes, we just have to use the specifics of the time, right? Or we have to use the specifics of that particular person. We just put the person's name there, put the person's hometown there, we'll put the person's favorite food there, we'll put all of those things there. It can serve lot of people. So that's it. We can reuse it multiple times. So that's the idea behind functions. So we can create our own functions. We can create our own functions. And then there are certain built-in Arduino functions. So first, we're going to be considering first, let's do this. First, we're going to be taking a look at some of the built-in Arduino functions. And then after that, we'll look at how we can create our own functions. But in today's session, what we're going to be doing is we're going to be using a very good strategy here. A very good strategy that solves the problem of our educational system. And I believe everyone in here, you'll appreciate what we're about to mention. Consider this. There's a class of students, right? There's a class. let's assume that class six students, and these students are always in class. They are studying. Now there are two teachers. One of the teachers, when he comes to the class and then he's teaching, let's take for instance he's teaching the multiplication timetable, right? So he's teaching 2 multiplied by 1 is 2, 2 multiplied by 2 is 4, 2 multiplied by 3 is 6, 2 multiplied by 4 is 8, 2 multiplied by 5 is 10, 2 multiplied by 6 is 12, 2 multiplied by 7 is 14, 2 multiplied by 8 is 16, in that order. So 2 multiplied by 1 is equal to 2, all the way up to 2 multiplied by 2 is 12, right? So this particular teacher, the first teacher, he teaches just the multiplication timetable from 2 multiplied by 1 to 2 multiplied by 12. That's it. He teaches nothing else. And he teaches the students not how they can how the concept behind the multiplication timetable. He does not teach them that. So for that particular scenario, you're going to find that students are unable to be creative. Students are unable to, if you ask a student, hey, what's 2 multiplied by 2? Quickly he says it, 4. What's 2 multiplied by 10? Quickly he says it, 20. What's 2 multiplied by 11? Quickly he says it, 22. What's 2 multiplied by 12? Quickly he says it. So you think his that particular student, he or she is so brilliant, but in actual sense, he or she is not so clever, right? Now, when you go beyond 2 multiplied by 12, and then you ask the person, what is 2 multiplied by 13? Just 2 multiplied by 13. He or she is unable to answer. And that's because the teacher failed to teach them the concept behind the multiplication timetable. So the concept is that if it's 2 multiplied by 1 or 2 multiplied by 2, you just add 2 to the next one, right? 2 multiplied by 3, you add 2 to the next one, like that. That's the concept, right? So the first teacher, he just teaches them how to recite the multiplication timetable for 2, the multiplication timetable for 2. So 2 multiplied by 1 is 2, 2 multiplied. So you're going to find that students are going to be reciting 2 multiplied by 1 is 2, 2 multiplied by 2 is 4. They are going to be reciting. And if any teacher asks them within that range, they are quickly going to answer. But if you ask them just 2 multiplied by 13, they are unable to answer. 2 multiplied by 15, it's worse. And then when you go further, 2 multiplied by 50, they are even unable to answer. And that's a very poor education. But let's take a look at a second scenario where we have a second teacher who is teaching the multiplication timetable. He does not waste time. He does not waste time to teach the students all the way from 2 multiplied by 1 is 2, 2 multiplied by 2 is 4, all the way up to 2 multiplied by 12 is 24. No, he does not waste time. All he has to do is just use about 3 or 4 examples. Just 3 or 4 examples. 2 multiplied by 2 is 2. And then he explains the concept behind how students can be able to obtain an answer whenever there's a question that 2 multiplied by a certain number, right? So he teaches them the concept using just about 4 or 5 examples. And then that's it. For such students, they are going to be clever. They are going to be brilliant. They are going to be creative. They are going to figure things out. So that's what's very important. So you can tell them, you can ask them, what's 2 multiplied by 255? They're going to tell you. What's 2 multiplied by 1060? They're going to be telling you, because they know the concept behind the multiplication timetable. So I believe that the former is a very poor system we have adopted for a very long time. And it's just our recitation, right? The teacher teaches recitation, and then how students can memorize things. That's it. That's just it. And when new problems come, students are unable to be creative enough. Students are unable to figure things out and then solve the problem. But we need to adopt the latter. We need to adopt the second example, the second scenario of us understanding the concept behind how how things work, the concept, and then we can figure things out. Anything that comes up, we can be able to figure it out. And so, in today's session, we're going to be going for the second scenario. We're going to be using that second system, and we're going to be learning our built-in Arduino functions. I believe you remember, if you do remember, when we started the program, there's one very important thing that we mentioned, and once I mention it, you'll be able to remember, and that's you do not need to know everything about electronics to build a system. No, you do not need to know everything about electronics to build that router. So if you come up, if Roddy comes together with Bernard, comes together with Michael Opoti, you come together with Isaac, Felix, Abdul Salam, everyone in team, Pius, all of you come together, and then you say you want to start a company that produces that router up there. You want to come up with a company that produces that. All you have to do is just do targeted research. You do not need to know everything about electronics. No, you do not need to know everything about programming. No, you do not need to know everything about mechanical design. No, you do not need to know everything, and it's not even possible. You can't know everything in electronics. No, since the 19 or even 18s or 17s, these people, the human race the human race has evolved, right? There are so many inventions that have come. There are so many technology has evolved so well. In the past, there used to be huge computers that take up huge spaces, but now we have a small laptop like this, and even we are still evolving. And so and all of these knowledge, all of these new things, or how new technologies that have come, new ways of doing things have been recorded in books, and even now in our age, with the rise of artificial intelligence, we have lots of data have been fed into a neural or thinking network, and then whenever we ask any question, it's able to go back in time from the working of when the Wright brothers, or when these American innovators, Rutherford, all of those people, French chemists, French innovators, all of those people were building atomic bombs, missiles, and all of those things. The calculations they did, all of those things, all of those data is there, right? Information is priceless, and then they feed it into a neural network that is able to think, and then we're able to ask questions, and then we get answers. And so that's just it. But there's also a different dimension of we being a people that also do research, right? No one has gone to Jupiter before, the planet Jupiter, and even as far back in time, no one had heard about Jupiter or certain planetary systems in our entire universe. But there's a different dimension of we doing research. So if you've not gone to Jupiter before, you don't know what the atmosphere looks like. You don't know the elements that are found on there, whether there's cobalt there, whether there's Mars, how SpaceX, Musk is doing all of these, trying to figure things out. We have a system that is only designed for us to memorize things, for us to just recite things for just recitation's sake, and then just memorizing them, and it does not really help. So yeah, the point is, you cannot know everything about electronics. You cannot know everything about mechanical design. You cannot know everything about programming. And in our introductory session, what we mentioned is, all you have to do is just do targeted research. All you have to do is just do targeted research, right? Targeted research. So you just have to know just a little bit about electronics, just foundational stuff, just basic stuff about electronics. Otherwise, that's how come we have so many people learning, they are learning programming languages, and they keep learning. They build nothing, no product. They build nothing, and then at all point in times, they feel they do not know enough, or they have not learned enough. No, that's not a good that's not a good situation to be in. That's not a good strategy. All you have to do is just know that when you go to a supermarket, there is a part where you're going to find clothes. There's a part where you're going to find vegetables. There's a part where you're going to find milk and dairy products. There's a part where you're going to find spray, cologne, cosmetic product, cream, all of those things. And then there's a part where you're going to find teddy bear, those things. There's a part where you're going to find shoes. There's a part where you're going to find jewelry, right? So all you have to do is just know the the classifications, right? And that's why classification is very, very important. You just need to know where to find what, and that's the only thing. So the first teacher, he teaches students just how to recite. 2 multiplied by 1 is 2, 2 multiplied by 2 is 4, all the way up to 2 multiplied by 12. And then they can answer all questions in that range very, very quickly. But whenever you go out of the range, 2 multiplied by 24, they have no clue. They are unable to solve it. But you can choose to be that particular student who does that, or that particular person who does that. But you can also choose to be, and you're never going to be able to figure out new things. But if you choose to be the second person, where you say, okay, I do not need to know everything about I do not need to know 2 multiplied by 1, 2 multiplied by 2, 2 multiplied all the way up to 12. No, it's so long. All I have to do is just know the concept. All I have to know is just know the concept, how to figure things out. And then if I want to come up with a certain if I want to come up with a certain result, if a question comes up, 2 multiplied by 566, all I have to do is just use the concept, and then I come up with the answer. So that's what we need to be focused on. And if you use this strategy, you're going to figure things out. You're going to just figure things out all the time. Yeah, and so that's the strategy we're going to be using in today's session. You're not going to be taking a look at every entire built-in Arduino functions we have. No. That's sometimes if you want to cook rice, let's use this final example. If you want to cook rice, that generally or commonly or usually to cook rice, some people prefer cooking rice with, you're going to have rice, you're going to have water, you're going to have salt, you're going to have some people add oil, right? But some other people do not eat do not are unable to take in salt, right? Our grandmas, and some other people, when you go to the hospital, they tell you do not eat salt or do not eat oil. So it's optional, right? So the main stuff is just rice and water, and then you can just cook it, and then that's it. You're done. That's it. You're done. So if someone is not going to be using salt, there's no need for that person study adding salt or worrying about salt. No, he does not need to worry. He or she does not need to worry about salt. And if someone is trying to not eat lots of oil or fatty foods, all he has to do is just ignore the oil, right? All he has to do is just get water, rice, and then salt, and then that's it. He cooks rice, and then it's edible. He's able to eat it. So that's so simple, right? That's so simple. And so there are so many things. There are so many things about programming that if you are building a very simple system, for example, we can see blinds, window blinds behind me. If you want to build a system, these products are lots of people are purchasing this in Ghana and even across the world, right? So all you have to do is just, okay, you sit down and then you say, wow, you can just go to town. If you are living in Takrady or wherever you are, Kumasi or Accra or wherever you are right now, you can just go to a shop or to a shop where they sell lots of these, and then you can just buy one, and then you look at how it works, how it rolls, and then you say, okay, right after this program, I want to design a product, just a rolling mechanism, right? A rolling mechanism that has buttons. One for when you press the upper button, it pushes it rolls the window blinds up, and you push the button down, and it rolls the window blinds down, right? So for such a system, you do not really need to know everything about programming, because you're not going to be using everything, right? It's just like cooking rice. If you don't eat salt, there's no need adding salt. If you don't eat oil, if your doctor says don't eat oil, there's no need adding oil, right? So you don't need to know everything about them. All you have to know is, okay, oil exists, salt exists, right? All you have to just know is oil exists, salt exists. It may there may be a different situation next time where your doctor says now you are fit to eat salt, and then you can go and eat salt, or you are now fit to eat oil, and then you can add it. So for a certain product that you are building, you're not going to be using everything in programming. No. So all you have to do is just do targeted research. If you are building the system and it requires that you need to use certain built-in Arduino functions, like a very simple example in terms of electronics is when you are building a battery-powered system, and we know that our phone is a good example of a battery-powered system. There's a battery in it, and our laptops, there's a battery in it. There are so many systems that have batteries in them. But for a desktop computer, there is nothing like a battery in it. When there's light out, that's it. It gets its main power from our wall socket, right? Yeah, and so that's it. So if you are building a battery-powered system, then you can go for an integrated circuit that will be responsible for charging the battery. It will be responsible for taking 5 volts from your charger, and then it takes it little by little in, and then charges a battery that has been connected to that integrated circuit. So that's it. But if you are building a system that is going to be connected straight to the socket, then there is no need going for an integrated circuit that will be used for charging a battery, right? So I believe everyone in here, you get the concept. If you get the concept of what we are mentioning, give me a thumbs up if you get the concept so far. So you only have to do targeted research. All right, in team, that's great. Pius, that's great. Michael Putti, Isaac, Felix, all right, that's great. That's great. So yeah, if you are building a system, the requirements of the system, if you are building a system and you're supposed to use geometry, you're supposed to use calculus. For such a simple system like this, you're not going to be using, well, it depends on the complexity of the system. You're not going to be using a PID algorithm. No. You're not going to be requiring calculus in a programming. You're not going to be using proportional integral derivative. You're not going to be putting a lot of formula in the code on your microcontroller. No. But for some other systems, it requires that you need to calculate angles. So now you go into your math textbook, or you just go online and you take a course, or you study something. You just get your textbook and then you study geometry, and then you understand, and then you apply that in building a system. If you need to study calculus to build a system, then you study it, and then so I believe we get the concept. The concept is just when a particular system requires that you use this, then you learn about it. It's not just learning about all of them before you even build a system, and that's not possible. Our brains cannot store every information right from the time humans started evolving to now. It's not even possible. And so this is a very, very good strategy. And we're going to be using that in today's session. All right, enough of the introduction, enough of the talking. Let's go straight into Copilot. So that's what we're going to be doing. Let's go straight into Copilot. We're going to tell Copilot, or ChatGPT, no, let's use Copilot. We're going to be using Copilot. We're going to tell Copilot that, Copilot, tell us about built-in Arduino functions, right? Built-in Arduino functions. And when you mention built-in Arduino functions, like we mentioned, if you are going to be writing some digital signals onto a microcontroller, if you're going to be reading some digital signals from a microcontroller, that's when you use that particular function, right? That particular built-in function. There are a lot of built-in Arduino functions. So if you want to write signals onto pins and then receive signals from pins, that's when you use certain functions, right? But if you're not going to be reading signals from microcontroller, there is no need using that particular function. And so built-in Arduino functions, we use them depending on the project we are working on. And so what's important is that we need to know the classification. We need to know the categories of built-in Arduino functions. And then whenever we are building a system, since we know where to go to, like in a supermarket, if you want to buy meat, you just have to walk straight to the meat part and then you buy your meat. If you want to buy jewelry, you don't walk to the meat part. No, you just have to walk to the jewelry part and then you go for it. So we need to know the categories of built-in Arduino functions. There are some functions that are used for math problems. finding square root, finding squared of a number, finding doing some stuff. But you're not going to be finding the square root of a number in a system that you're going to be designing for this window blinds, then there is no need using that particular built-in Arduino function. But it's important that we know the various categories so that we know where to go to when we want to build such a system. And now with textbook, with our professor here, with our AI models in here, we can get information from billions of data, billions of information that has existed since humans we started evolving. So yeah, let's go straight into Chat GPT. No, Copilot, and let's ask Copilot to give us a breakdown. First, tell us what a function is, and then give us a breakdown give us a breakdown of built-in Arduino functions. All right, so let's click on Copilot here, and let's give Copilot just a second to load. Once you see Copilot, give me a thumbs up. Okay, once you see Copilot, give me a thumbs up. All right, let's just give it a few seconds. All right, great. All right, great. Okay, how can you sleep? What should we dive into today? All right, great. So I believe everyone is able to see. All right, so let's type in the prompt in here. Let's type in what we seek to learn. All right, so let's do that. Let's do that. So what we type in. So let's say tell us. Okay, so let's first say in Arduino programming, right? In Arduino programming, we want you to tell us about the various. Want you to tell us. Want you to tell us the various categories or the various categories or groups of want to tell us that the various categories or groups of built-in built-in Arduino functions, and examples each under each under each category. Yeah, examples under each category. Yeah, that's it. So let's see if this prompt will do the magic for us. In Arduino programming, we want you to tell us the various categories or groups of built-in Arduino functions and examples under each category. Not necessarily every function under each category. So that's it. Let's now click on enter. Let's click on the upload here, and let's see what a Copilot is going to be giving us. And that's it. We are figuring things out. We're not trying to recite the multiplication timetable. No, there is always going to be an occasion where we're going to be needing certain built-in Arduino functions. But all we have to do is just we need to know the structure, right? This is there are some functions for math. There are some functions for controlling input-output pins. There are some functions used for reading, for serial communication between your computer and then your microcontroller. There are some functions that are used for reading signals, for reading analog signals. That's yeah. So just those categories, and then whenever we want to build a system that we think we are going to be needing a certain function, a certain keyword that will be performing a certain function for us, all we have to do is just do a search on that, do targeted research, and then we figure it out and then add it into our system. So yeah, let's not make this let's not make this. Let's go off video. And yeah. So yeah, so number one, okay, let's read what it's saying here. Arduino's built-in functions are grouped into categories based on their purpose and functionality. All right. Okay, so it's giving us a breakdown of the main categories with examples under each to help us navigate Arduino programming more intuitively. So that's exactly what what we want to achieve. All right, so control structures. Control structures. All right, these are not functions per se, okay, but essential language constructs that control the flow of your program. And we've learned about this. If else condition, if else, right? Switch case, we've learned about this. These are used for control logic. We want to make decisions. So if this, we want you to do this, else do this. And we say switch between these cases. In case the number is this, we want you to do that. All right, so that's so simple. So this just as it's saying here, it's saying these are control structures and they are not functions per se, because if else, it's not only found in Arduino programming. If else is found also in Java. It's found also in JavaScript. It's found also in C++. It's found also in C#. All of the programming languages, they have control structures like if else, switch case, for loops, right? For loop, while loop, do while loop, break, continue, return. All of these, they are in there. But now let's take a look at the built-in Arduino functions, right? Yeah. So digital input output. Digital input output. And then let's take a read. It says used to read from or write to digital pins. It used to read from or write to digital pins. So yeah, we use these functions in here, these functions or keywords in here. We use them to read from digital pins or write to digital pins. So we read digital signals from the pins and write digital signals onto those pins. And remember, we mentioned that for microcontrollers, there are pins on there. There are pins on every microcontroller. And for those pins, there are 7 pins that can do digital, right? They can do digital input, they can do digital output. So for those pins, we use these functions, right, to perform to perform certain actions on them, right? So we use these functions that have been written here to read from and write digital signals onto them. All right, let's take a look at the first one here. Just a few examples. Pin mode, pin mode. And I believe everyone in here, you remember pin mode. Pin mode is when we want to tell the microcontroller that, hey, microcontroller, your pin 2 is going to be used as output, like, right? So your pin 2 is going to be used as output mode. It's going to be in an output mode, or it's going to be in an input mode, right? Yeah. So that's the first one. So simple, right? So we have digital input output functions, and there are a lot of them, right? But these are just a few of them that we need to take note of. So it's not about reciting the entire multiplication timetable for 2 multiplied by 212, 224, 236. It's not about reciting all of them. No, it's about knowing just a few of them. And then whenever we are building a system and we need a specific one, we just do targeted research. We just do a research that targets the problem we want to solve, and then we can figure it out. We can find a function that does a certain action or a certain purpose for us, serves a certain purpose for us. All right, but now for we take a look at just these 3. Pin mode, yeah, it tells the mode of the pin, whether output, whether input. And then we have digital write. This one we want to write a digital signal onto a pin. So just as we saw, when you connect an LED or any components to the microcontroller, and we want to write digital signals, whether on or off. And we know digital signals are just on and off. Digital signals, it's just 1 or 0. 1 or 0. These are just the 2. So it's either 1 or it's 0, right? It's either on or off, right? Yeah. So we use a digital write. We use a digital write function here to turn to send some digital signals onto a microcontroller's pin, right? And then that in return that in effect is going to send that signal that has been sent onto the pin into the component that has been connected to it. So if you connect an LED to a pin 2, it's going to send a digital value, right? A digital signal, right? And that's the value here. So we can say high or low. So we say digital write, and then we bring our bracket open, bracket close, and then we put the number here, the pin there, and then we put the value, right? The signal we are sending, right? The value or the signal. So we can say high. We can write high here, or we can write low here, or we can write just the number 1 here, and that's going to turn the pin on. Or it's going, or write 0, and then that's going to turn it off. So that's it. So that's digital write, right? So for the digital write function, it takes in two parameters in here, right? So whether we are connecting a red LED, whether we are connecting a blue LED, whether we are using pin 1, whether we are using pin 2, whether we are sending a signal of low or high, all we have to do is, this is like myself that has been written for us. This is like myself. It's like my name is dash. I come from dash, right? So depending on the person that is using the template, depending on the person that is using the function, he or she is going to put his or her actual name at all of the parts that have dash 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 there, right? So if I am using the template, the myself template, and then it says my name is dash, I'm going to put my specific name there, Kingsley Kwesi Mensah. I come from Takrady, and I put my my hometown there. But if Bernard is writing it, Bernard may put his actual name there, Bernard, right? And then he puts his hometown there. His hometown may be different, and he just puts his hometown there. So so yeah, there's a function. So the function is digital write, and then we can put the pin number there, those parameters, right? The specific parameters. And in our case, the parameters are just our name. So I put my name here, and I put my hometown here. And at the end of today's session, you're going to create your own function, and then we will learn how that's that. It will be quite interesting. But yeah, for digital input output, whenever we are building a system and we need to do digital input and output, we can use these functions in here. We can use pin mode to tell the mode of the pin, whether output or input. We can use digital write to write signals or send signals onto a pin number, right? We can send a high or low signal. And then we have digital read. Digital read is a function that just takes in the pin number, right? So it reads digital signals from a certain pin. So if you are working with, let's say, pin 2, digital pin 2 of your microcontroller, or digital pin 5 of your microcontroller, all you have to do is just put the pin number in the pin number. That's the parameter, right? That's the specific parameter. So you just put the pin number in there, and that's it. It's going to read the signals, the on and off signals that are coming from that particular pin. That's so simple. And apart from these three examples here, we have a number of other digital input output functions, right? But it depends on what you are doing. So if you are building an autonomous delivery robot, if you are building a system that will be used in an aluminum manufacturing company, if you are building a system that is going to be monitoring the weather, going to be monitoring pollution at certain companies, right? Yeah, all you have to do is just use the required or the essential the particular function that is going to be needed by your system to function, right? Or to work. That's it. So simple. But yeah, for digital input output, these are just three examples we have taken a look at. When you're building a system, just do targeted research, and then you're going to find out about other digital input output functions that can be able to be used. All right. Then we have analog input output, right? Analog input output. So whenever we want to output analog signals, whenever we want to input analog signals into a microcontroller, or to send analog signals out of the microcontroller, we use these analog input output functions, right? Yeah. And so we can say analog read. And so if you are working with a sensor, and that particular sensor is an analog sensor, and that analog sensor is going to be giving you some analog signals, like like a potentiometer. A potentiometer is an analog sensor. A light dependent resistor, an LDR, is another analog sensor, right? So when you connect such sensors to one of your pins on your microcontroller, those sensors are going to be giving you analog signals. And to read them, to write instructions onto your microcontroller to read those signals, you use the function called analog read. Analog read, right? So you just say analog read, and then you put the pin number on there. So if you have connected a sensor to pin A0, or to pin A1, or to pin A4, or to pin A3, or to pin A5, all you have to do is just write your pin number here, and that's it. It's going to read the analog signals from that particular pin, right? So you just say analog read, and then you put the pin number on there. So if you have connected a sensor to pin A0, or to pin A1, or to pin A4, or to pin A5, all you have to do is just write your pin number here, and that's it. It's going to read the analog signals from that particular pin, right? Yeah, good. And then we have analog write. So that's when we want to write analog signals onto a certain pen, right? And yeah, so analog signals. This is in a form of PWM signals, and we're going to be appreciating PWM. And I believe some of you know a little bit about PWM. It's pulse width modulation. Pulse width modulation, and that the word modulation needs to speak something into your ears. When you say modulation, what's the meaning? It means it's like we are modulating something, right? When you go to the hospital and someone has been oxygen has been put on someone, and usually when doctors are doing surgery, right, they are always monitoring the patient's heartbeat and all of those things. And then you see the heartbeat moving up, moving down, moving up, moving down. So that's it, modulation. So it's like and modulation can be, increasing something and decreasing something, increasing something and decreasing something. So yeah, analog, right? It's used to send PWM signals, and PWM signals, pulse width modulation signals. It's just some signals that go up and then go down in a certain way. We're going to be learning about it in a certain way, and that is considered as analog signal, and we write it onto certain component. Like if you want to turn an LED, sometimes you can turn an LED just on, you can turn it just off. But what if you want the LED to, just pretend you want the LED to behave as if it's closing its eyes slowly and opening its eyes, slowly in that particular order, in that particular manner, right? So you can use the PWM, you can use PWM signals to do that. And sometimes if you want to control the speed of motors, so if you are building this particular system that we mentioned, a system that is going to be used on window blinds, right? You want your motor, you want to be able to tell the speed at which your motor should run. If you want your motor to run very, very fast, when a user presses a certain button, or you want the motor to run very, very slowly, right? So that's it. You can use analog write, the analog write function. You just put your pin number in there where your component has been connected to, and that's it. You can put the value there. And the value is just the signal, the analog signal, the pulse width modulation signal you are writing in there. So you can write something like 0, right? You can write something like 255. You can write something like 100, and that is going to be sent onto the motor to tell whether you should run very fast or you should run very slow, in that order. So yeah, that's it. If you are building a system like this, you are definitely going to be using something like analog write. And it depends on the component you're even using. Sometimes you want to use a stepper motor, and a stepper motor has what we call it. They use there are yeah, we're going to be going into that, and that's our last session. You cannot miss it. Libraries. What are libraries? Libraries, they look like functions, but they are more advanced, right? Libraries look like functions, but they are more advanced. They also do specific things. So if you are working with a certain component, like a certain GPS module, right? A certain GPS module that can be able to help you locate that can be able to help you get a location, that can be able to help you with the navigation of your system. All you have to do is, these electronic systems are produced by companies, right? It's just like buying an Apple computer. Apple is going to tell you how to use a computer. It's just like buying a Dell computer, an HP computer. Those companies are going to tell you how to use them. And so it's the same way when you're working with a certain electronic component like a GPS model, or an IMU, a national measurement unit, or any simple module at all, any simple electronic component. Um, those manufacturers, they have written some code, and that's what we call library. They have written some code to help simplify your work, right? To help simplify the work of engineers. So if you come together and you say you want to build a certain system, and a system is going to be using a certain microcontroller or a certain component, a certain electronic component, and you have to program that particular component. All you have to do is just get the library from the manufacturer, and then that library, it's like a function. All you have to do is just put specific things in there that is going to be um, happening on your system, and that's it. It simplifies your programming. So I believe that's a simplified introduction a very simplified introduction to libraries. But yeah, we're going to be taking a look at that in tomorrow's session. Let's quickly run through these, because once we go up to this session, you can just as we mentioned, it's always about targeted research. It's not about recitation or knowing everything in programming. No, it's about what you are building, the project you are building. If you are building a project and you do not need salt, there's no need learning about salt. There's no need memorizing a whole lot of salt stuff in your head. You're not going to be, if you're working on a project and the project is not going to be requiring you to add oil, there's no need learning about oil and then memorizing lots of stuff about that's going to be quite stupid. So yeah, that's exactly what you're doing. What you're doing is a smart way of doing things. Yeah. So analog reference. That's another function that is used for analog input and output. And you do not need to know about this until you're working on a solution or a product or a project, right? But well, you can just read a little bit about it, but do not waste time learning, going into detail, right? Because you know the categories, you know where to find milk, you know where to find fruits, you know where to find all of those things. And then timing, we have certain functions that are used for timing. And so if you want to add to add some timing into your project, for example, for this particular project that we mentioned, you're building a project that these people, a product for people, they're going to just be connecting it to their window blinds, and then they press a button, it moves up, they press a button, it moves down, and you want to keep track of time. Well, this particular system is not going to be keeping track of time, but there are certain systems that are going to be keeping track of time. For example, we are building a siren system for certain school. Right after this program, you just saw a siren system is so simple. Some schools still use bells, even though they are teaching technological stuff. They are teaching math. They are teaching these things, but they still use bells, right? In high schools, some high schools do not use and junior high schools. And there are so many junior high schools in Ghana. And so right after the program, you have a huge market. You can just go onto the website of GES, Ghana Education Service, and then you look up the data. How many primary schools are in Ghana, or how many junior high schools are in Ghana? And all of these schools are using bells, right? So you just look it up. You just say, okay, I'm going to be requiring this component. I'm going to be writing this code. I'm going to be using for the code. I'm going to be requiring I'm going to be keeping track of time, right? So if it's 12 p.m., the system is able to know when it's 12 p.m. The system is able to know when it's, and if you want to do some delays, pause for a second, pause for 5 seconds, pause for 5 microseconds. All of these things are just timing. And so you just do your research, just targeted research that is targeted towards something you want to build. That's what was important. So you look up the data and then you do your calculation. And at the end you say, okay, this product is going to be costing, and that's where the business comes in. So this product is going to be costing this siren that they're going to be building for junior high schools, it's going to be costing, let's say 100 cedis or 120 cedis, or yeah, 120 cedis, and then that's it. You have business. And then if there are 1 million junior high schools in Ghana, which I believe may be more than, so you just multiply 1 million schools by 120 units of the product that you design, and then you can know how much money you're going to be, how much business is going to be coming out of this. But yeah, so if you want to keep track of timing, you want to keep track of time, you want to do timing, right? You're going to be using, there's a function called delay, right? And I believe we saw how that works when we wanted to keep the light on for a certain amount of, we're going to be doing that. So we have delay, we have millis or millis. So it's just milliseconds, right? So it's just milli, and then the S stands for seconds, right? So milliseconds, so millis, or you can say millis, or yeah. So any of them works, and that's what this particular function returns. It gives you the time when the system was turned on, right? So immediately the system gets turned on, immediately the system gets turned on time, right? So that if it's just like, you go onto your phone and you turn on your stop clock, right? your clock like this one. I think we can take a look at this. Yeah. Stopwatch. So you can just press start, and then you can see that the time keeps counting. So that's the millis function, or the millis function. So it can help you be able to know if your system has been on for an hour, the system has been on for 30 minutes. When you're building a system and it requires timing, these are functions that you can be able to use. But yeah, we also have microseconds, so micros, right? It gives you the time, it returns the time in microseconds, and we have delay microseconds. It's used for shorter, pauses in your system. And we have interrupts. So we have a wide range of categories of functions built in Arduino functions. So all you have to do, you may want to search this up and then print. You just have to write that, okay, we have functions that are used for timing. We have functions that are used for interrupts. We have functions that are used for math. We have functions that are used for trigonometry. The functions that are used for serial communication. And serial communication is when you want your microcontroller to speak with your computer. So these are a number of them: serial.begin, serial.print, serial.println, serial.read, serial.available. And we have bit and byte manipulation. When you want to manipulate bit and byte manipulation, and this, you're going to find this very important when you want to you want to package data and then send it via a certain communication protocol, a wireless communication protocol or something. Or when you want a microcontroller to speak with one another, you want to send data onto the other in bits, or yeah. So do some research on bit, byte, these bit, byte, kilobyte. Do some research on that. 8 bits is equal to 1 byte. Those things. And sometimes they will tell you that a microcontroller is an 8-bit microcontroller, a 10-bit microcontroller. Those things. So do some amount of research on that, and it's based on it's going to be dependent on the system that you are building. So if you're building a system, you're not going to be using trigonometry. You're not going to be using these functions in here: sine x, cos, and then you put your number there, tan, and then you put your number there. No, right? You're not going to be using serial communication. If your system is not going to be requiring that the microcontroller speaks with your computer, there's no need using these functions. But you just need to know that there's a part where if I want to find functions that will be used for my microcontroller to speak with my computer, we have some functions that are going to be used for that. We have advanced input outputs, right? So you have pause in, you have shift out, we have tone, we have no tone, and so many other functions. And you have utility functions. We have utility functions: random, minimum, maximum. We have random seed. All of these functions. So I will have utility functions, advanced input output functions, bit and byte manipulation, serial communication. We have functions for trigonometry. We have functions for math. We have functions for interrupt. We have functions that are used for timing. We have functions that are used for analog input output. We have functions that are used for digital input output. And this may be different when you ask a different AI model, or when you visit different textbooks. But what is important is the categories these functions are in. And whenever you're building a system, you just have to just go into or search for the specific function you want to use, and that's it. You figure it out. You just build your system. All right. And then if you want to make it more effective, you just find ways to make it effective. That's it. There's nothing like memorization of these functions in here. No, there's nothing like that. As you keep on building systems, when you build a system for an aluminum manufacturing company and you use about 10 functions in here, you've made progress. You know about them. And then you go on to build a system for a railway company. And then for that particular project, it requires that you use different functions. And then you have seen that function before. So that's it. That's essentially what needs to happen. You don't need to memorize all of these functions, and you can't even do it. You can't even do it. Well, nothing is impossible, but some things are just silly. It's just silly to do certain things. Just memorize things that you always you always can refer to. Memorizing things you always can refer to. Sometimes it's silly. Sometimes it's good. But well, yeah. So that's the point we're making. But yeah, I believe the first part has been covered. We're taking a look at built-in Arduino functions, and up until now, give me a thumbs up if you're a little bit good with functions. Functions are just, templates that have been created so that it can be fit into wherever it needs to be in. So if there's a template on myself, it can be used by Michael Oputi, it can be used by me, it can be used by Bernard, it can be used by Isaac, it can be used by Roddy, it can be used by anyone, it can be used by Felix, it can be used by it can be used by anyone in here. We just have to put our specific details in there. All right, now let's learn how to create our own functions. Let's learn how to create our own functions, our own simple functions. Yeah, let's do that. Let's go off video. And please give me a second. Please give me just 2 minutes. All right, we are back. Thank you. So yeah, let's look at creating our own functions. Our time is almost up. Let's do this very, very quickly. Let's go into Arduino IDE. Let's go into Arduino IDE and let's take a look at this quickly. Give me a thumbs up once you can see my Arduino IDE. Give me a thumbs up once you can see my Arduino IDE. Let's just give okay, it says can't share my screen. Let's go for our trusty friend. Okay, let's stop sharing completely and let's go back into sharing window Arduino IDE, and I believe it's going to work now. Once you can see my screen, please give me a thumbs up. Okay, still says can't share my screen. All right, let's share my entire screen then. I believe there's a last option. This is going to work. All right. I believe everyone is able to see my screen now. Arduino IDE here. All right, great. All right, great. Michael. All right, Bernard. All right. So now, yeah, this was for this was our session. All right, Rudy. That's good. This was our session for yesterday. Let's take everything off. Right. Let's take everything off. Let's take everything off. We have two parts in our. All right, Isaac. We have two parts in our Arduino code. The setup part, the loop part. Let's create them. Void setup. Void setup, bracket open, bracket close, and then we bring our curly bracket open, curly bracket close. That's setup part. And then we have loop part. So void loop, bracket open, bracket close, curly bracket open, curly bracket close. That's the loop part. All right. And then we have the top part up here. All right. That's where universal start. If you write something here, it's going to be seen by both the setup and then the loop part. All right. That's great. So simple. All right. Now let's look at how we can create our own functions. All right. So let's put a comment here. Let's put a comment here. Let's bring our forward slash, and then we bring an asterisk sign. And now everything we write in the middle here, we seek to create functions, right? So functions. All right. That's what we seek to do. We seek to do. But to create our own functions, there are two things we need to take note of, right? There are two things we need to take note of. And for you to appreciate this, let's use this illustration, this very simple illustration. Back when you were in high school, sometimes a teacher would send you to go call a colleague of yours, right? So let's use so Isaac and Felix are colleagues, right? They are both in school, and Felix is in class, and Isaac was on a school campus, and then he saw the math teacher, and then the math teacher mentioned that Isaac goes to fetch Felix for him, right? So the teacher says, "Hey, please go and then call your friend for me." And then he goes and then calls him that, "Hey, this teacher is calling you," and that's it. There are two things that can happen. There are two things that can happen here. So the teacher may say, "Okay, um I want you to just go ahead and call your friend for me." So when you go, you can just tell him to come, and then your friend is just going to come. Felix is just going to come, right? And then you can just stay. You can just stay in your classroom. So all the teacher needs is that he calls that you call your friend for him. That's it. So simple. So in this particular example, there's nothing like returning. There's nothing like you going, calling your friend, and then coming together with your friend to the teacher, right? So you see your teacher, your teacher tells you, "Hey, go and call your friend for me." You go to the classroom, and then you tell your friend, "Hey, the math teacher is calling you," and then your friend rushes back, he runs to the teacher, and then you are still seated in the classroom. So that's the first thing, right? That's the first thing. You can sit in the class and then do your own stuff while your friend is going. And then the second thing is the teacher may be specific and then say that, "Hey, when you go and then call your friend, come together with him," right? So return with him, right? So both of you are going to come. So those are the two things. So we have functions that whenever we want to create functions, we have functions that are going to not return anything. They are not going to be giving us anything. So we can create a function to turn LEDs on. Can create a function to turn an LED on, turn a motor on, and let's say turn a heater on, right? You can create a function to turn a motor on, turn a heater on, and turn a light on, right? So this is just a function that is just going to be sending signals to those components. It's not going to be taking back information from them and returning them. So yeah, we have functions. We have functions that uh, returns nothing, right? Will return no feedback, right? Feedback. All right. Yeah. So we have functions that will return no feedback. All right. And then we have functions that will return feedback. So will return feedback. All right. So this is when you're doing something like x plus y, or you have two sensors on your system, and then you say sensor one's value should be added to sensor two's value, and then it should return the sum of these values, right? It should return to you the sum of the values. So that's it. So we have the first instance where you are creating just a function for LEDs to turn on, for motors to turn on, for certain components to turn on. And for that particular application, you are not going to require any feedback from those things. You're just going to send something to it, right? But there are some other functions that will return a certain feedback. For example, if you say x plus y, right? If you say 2 plus 5, it's going to return a value back to you as, let's say, 2 plus 5 is equals 7, right? So it's going to return a value of 7 to you. And then you may say that, okay, that you may write in your code, in your system's code, you can say sensor one's value should be added to sensor two's value. And then after doing the calculation, we want you to return the sum of the values, right? Want the sum of value to be returned. And when the sum of value is returned, then we divide the sum of value, the sum of the sensor one and the sensor two by 2, right? So we divide it into 2. So that's it. We have functions that are going to be just that will return no feedback, and then we have functions that are going to return a feedback. All right. I believe we are good with that. I believe we're good. So these are two things, just two things. When it comes to functions, these are just the two things we're taking a look at. All right. So functions that will return no feedback, and then functions that will return feedback. And sometimes in other systems, you may write a function that is going to, even though it's going to be sending signals onto a motor to turn on, or to an LED to turn on. When the LED turns on, you want to find out whether the LED turned on or it did not turn on. And that's when we looked at certain functions that I used to do digital input output. And I used to do certain other, specialized, advanced or specialized stuff, right? And I think it's called pause in. So it's PUL, right? So let's write that in here. I believe you can see it. It's just pause, right? Pause and then capital IN. Let's see if that changes. Let's see. Yeah. So yeah, that's it. Pause in. So that's it brings a feedback and it says that, okay, I think pause in is used for timing. I think it's a timing function. But yeah, you can just go through the categories and then just figure out where to find it. But yeah, for certain systems, failure is not an option. Failure is not an option. And even when something fails, we need to know whether something has failed. For example, satellite. If you want to build a satellite and then launch it into space, and a battery is not working on the system. A battery, you can attach a sensor to a battery and then receive signals. But there are some components that you send signals into, you do not receive any signal from. Some of them are an LED, right? So if you send a signal into an LED, it may turn on, it may turn off, and then there can be a time where the LED is destroyed. The LED is spoiled. How will you know that the LED is spoiled? And that's when you need to get feedback from whether the LED has turned on. It's just like when they say who's watching the watchman, right? When you send someone to go and spy on someone, you send another person to spy on that person, right? So that's it. So you send signals into the LED, right? Under normal circumstances, the signal is just going to go. The signal is just going to go with even if the component is destroyed. If the component is not destroyed, the LED will turn on. And if the LED is destroyed, if the LED is spoiled, it's not going to turn on. But there is no way you're going to find out. And in order to find out, you need to write a certain function, right? You need to write a certain function that will just monitor things and then give you a feedback from whether the LED turn on or it didn't turn on. And then if it did not turn on, right? If it did not turn on, you may say, okay, it should return a value of 0 if the LED did not turn on. But if it turned on, we want you to return a value of 1, right? Yeah, so that's so simple. And yeah, that's so simple. And then you can tell the function to return that particular value so that you have at least a feedback to know that whether the LED has a problem or does not have it's working fine, right? Yeah. So certain output components like motors, like LEDs, even though we usually send signals into them and we do not receive any signal from them, sometimes if you are building a very high profile system, and that system, there's no space, you can compromise, there's no space for any errors. So you have to just you have to receive signal back from those motors. Even though they are normally we do not receive signals from them, you need to receive something like that to make sure that, okay, the motor is working fine, the LED is not dead, right? Yeah. But yeah, let's see how we can write our own functions. So to write a function, let's first take the first one, a function that will not return any feedback, a function that will just do an action for us. It will bring us no feedback. We just write void, right? Just write void. Oh, let's not write it in a void part. Whenever we want to create a new function, I think we don't write it in the setup part. We don't write it in the loop part. We can write it outside of them, right? So you can write it below here. We can write it down here, right? And then if we want to let the function run, we write it. If we want the function to run just once, we put it here we call it in the setup part. Or if we want it to continuously run, just as we took a look at the loop part, right? We mentioned that There are two parts in Arduino code: the loop part and then the setup part. The setup part, it just runs once. Like a driver, he checks his light, his mirror, he checks his engine, he checks his engine oil, he checks the the tires, and then that's it. Set up for the day. He's not going to do it anymore. It just runs once. So yeah, but yeah, we're going to be appreciating this. But yeah, let's go straight into it. We're creating a function that is not going to be returning any value for us. It's not going to be returning any value, right? A function that is just going to be turning an LED on and off and will not bring us any return feedback from the LED, right? So let's create that. And to create that particular function that will return no feedback, we use the word void. Void. And I believe everyone in here, you know the meaning of void. Void is empty. Void means empty. Remember in the Bible in a creation books, when it gave an account that when God created the universe, it was void and empty, right? It mentions something like that. It was void and empty. And then yeah, and then it goes on to say God separated the firmament, and then he called light, that let there be light, and there was light, and all and those other things that God did. But the meaning of void means empty. So if you buy if you buy a bag, and then you put something in it, and then someone asks you, is there something in the bag? You say no, the bag is void, and it means the bag is empty, right? There's nothing in the bag. Or if you say there's something in the bag, then it means yeah. But yeah, void means empty, right? Empty. Empty. All right, so that's void. So void means, yeah, it's not going to be returning any value. There's nothing that is going to be there's no feedback that is going to be coming from this particular function. So it's just void, nothing, just empty, right? Yeah, so we just write void, and we'll write the name of the function that we want to create. So let's give the function a name. Let's say the function is the name of the function is add. The name of the function is add sensor. Yeah, add sensor one, right? Add sensor one. No, so let's create this. Let's say add numbers, right? Add numbers. Yeah. So let's create a function that is called add numbers. No, this is going to return some value, but we're saying a function that is not going to be returning anything, right? Function that is empty. So is it void? Void. And let's say the name of our function is turn LED on and off, right? So just say turn the name of our function turn on and off, right? Turn on and off. Yeah, so that's it. So simple. And then what else do we do? What else do we do? We put a bracket open and then bracket close here, right? And what goes in there is our parameters, right? Our parameters. Remember when we were writing the template, for myself, we said my name is Dash. I come from Dash. I am Dash years old. So that's it. So so in here, that's where people are going to be putting the actual things that concern them in here, right? So it says turn. Oh, come on. We still are talking about the function that is going to return a feedback. But yeah, let's create a function that is not going to return a feedback. But yeah, so this we can say pen number, right? We can say pen number, comma, duration, right? Duration, right? Duration. So we can say the pin number, the user needs to input tell two things. So dash dash. So these are the two things, two parameters that our function is going to be taken. Our function is always going to be requiring. So if you write a myself template, my name is Dash, I come from Dash, I am Dash years old, then it means there are going to be three parameters in there. The person tells their name, they tell their age, then they tell their where they come from, right? So there are going to be three parameters. But for this particular one that we are creating, want to turn an LED on. And we know that to turn an LED on, you need to tell the pin number where the LED has been connected to. And if you are turning it on, how long do you want to turn it on? How long do you want to turn it off? So the duration, right? So if you are creating a function, you need to know the parameters involved. So if you are creating a function that is going to if you are creating a function that is going to ask people to, if you are creating a function that is going to be adding 5 numbers, right? There are going to be 5 parameters. So you say first number, second number, third number, fourth number, fifth number, and then people are going to be typing in those numbers into the dash dash, those spaces that you have created, those parameters that you have created. So in this particular regard, when we are done with this particular function, all the user has to do, all we have to do is just type in the pin number here. So if it's pin 2, we just have to put 2 there. If the duration is, let's say, 5 seconds, we say 5,000. It's 5 seconds. What's 5 seconds? Is it 100? 500. 1,000 milliseconds is equal to 1 second, right? So if we want 5 seconds to happen, we write 5,000 here, and that 5,000 milliseconds is equal to 5 seconds. So yeah, that's it. So it takes in the pin number, and then it takes in the duration that the LED is supposed to, the light is supposed to be on, like be off, right? Yeah. So now let's undo. But when we are creating the function first, we need to just we need to just write a word here. We need to just write a certain word here, and that is going to, this word, it's just like you're creating a variable, or you're creating like a representation, right? It's just like you're creating a representation, right? Just like you put dash there. My name is dash. It's just like saying dash here, right? And then I come from dash. So you just do that. But you're going to understand this further. So if you're creating a function that is not going to be returning any value to us, it's not going to be giving us any feedback back after the function has run, we just use the word void. So it means that the function is void. It's not going to be giving us anything. The function is empty, right? So void, and then we write the name of our function, right? Turn on and off. And we know that this is a name that we have come up with. This is not a name that there's not a built-in Arduino something, right? We know that when you write something like pin mode, and then we bring this, right? The Arduino, this is a special function that was designed by the Arduino platform themselves, right? But this is also our function that we are creating, and so it's also going to be orange. So do not get confused about the built-in Arduino functions and our own function, because someone you may have expected that since it's our own word that originated from us, it would have been in white, right? But no, since it's a function we are creating, it's going to have an orange color. So we say void turn on and off, and then we put the parameters in here. We say, okay, whenever a user is going to use this particular function that we are building, the user is supposed to put in the pin number and then the duration, and that's it. So simple. And what else do we do? Let's take a quick look at the syntax for the syntax for let's take a look at the syntax for syntax for creating a function. All right, since we mentioned, let's just quit this. Let's take a look at this. Okay, tell us the syntax for creating a function for creating our own function in Arduino programming. All right, so we click enter, and let's see what is going to be given us. All right, so let's see. Okay, so yeah, so return type. All right, so if the return type is void, if it's not going to be giving us any return type, then we put void there. But if it's going to give us a return type, yeah, we're going to be talking about it. But yeah, we write that the function name, and then we bring our bracket open and bracket close, and then we'll put our parameters in that bracket, and then we bring curly bracket open, curly bracket close, and then we write all of the things that we want to do, the code to be executed. And then if it's going to return a value, write return value. If it's not going to be returning any value, we just don't write anything there. All right, so I believe we've gotten the syntax. It's so simple. Yeah, this goes forward to just mention that we do not need to know everything about programming to be able to work on a system. All we have to do is just do targeted research, right? We want to cook rice without salt. If we don't need salt, there's no need learning about salt. All right, so yeah, let's go into it. All right, so we say void void. Since it's not going to be returning anything, we say void. So void, turn the name of our function, turn on and off. Then our parameters, they're saying, okay, this function that we are going to be creating, we know that this function is going to be used so many times in different instances in our code. And we want to reuse this particular function we are creating. And so we have put parameters in here. Put parameters, just some words in here that represent what users are going to be entering into this for it to do what it's going to do. So to turn an LED on and off, we say it's going to be requiring pin number, and it's going to be requiring the duration, whether what the duration it's going to be on and off. Yeah, how long. All right, and then we bring our curly bracket open and curly bracket close, and then that's it. We have created our function. This is the function. But in here, we need to write what our function is supposed to do, right? What our function is supposed to do. So what is our function supposed to do? Our function is supposed to turn light on and off, right? So let's write that the on part. Let's write the on part. For the on part, we say digital write, right? And we're using a built-in Arduino function, but that's not a problem. So we say digital write, and we say pin number, right? So we're writing the instructions to turn a light on, right? So pin number, and then we say high, pin number high, and then we bring the semicolon here. You're going to appreciate this, but like we mentioned, sometimes you hear something for the first time, it's going to sound something. But yeah, do not get worried. The digital right, and we say pin number, right? What do we put here? Parameter pin number high, right? And then let's say delay. No delay. It's how long should it last? It should last how long the duration is, how long that the user types in here, right? Yeah, how long the user types in here, the duration. All right, so we type that in here. All right, good. So that's it. And then we say digital right, it should turn it. So that's for the on part, right? That's for the on part. And then we say digital right, pin number, pin number, pin number low, right? That's when we are turning it off. And then we say delay duration, duration. All right, that's it. So simple, right? So simple. All right, so yeah, that's it. So simple. So we have created our function. Now what we have done is if a user wants to use this particular function that we have created, if we want to reuse this function that we have created, we know that this function does just two things. It turns the LED on for a certain period of time, for a certain duration, and then it turns it off for a certain duration, right? So we do not have to come here and then keep typing the pin number, keep typing the duration so many times, multiple times. No, all we have to do, right, after creating the function like this, all we have to do is just come to the, if depending on where we want to execute the function, we want to call the function. And calling a function is just, it just means you want the function to now be in action, right? You want the function to now be used, right? So when you want this function that you have created here, you created a function called turn on and off, right? That's the name of the function. If you now want this function turn on and off to be in action, if you want it to start working, right? All you have to do is let's take for instance, we want that the function to run, want the function to work in a setup part. So all we have to do is just come in the setup part, and then we say we type the name of our function, turn, right? Turn on and off, right? And then we bring bracket open and bracket close, and then we bring our semicolon at the end. And then in here, in the middle here, that's when we write the name, the number, the pin number, right? The pin number, right? And then the duration, how long we want it to last, the parameters, right? So if you create a function and then you say the function is going to be taking two parameters, pin number and duration, you cannot write three things in here. You cannot write three parameters in here. because when you created it, you said it's going to be taking just two parameters, right? Yeah. So you have called the function here. You say you just write the name of the function, turn on and off, and then you put a pin number there, right, of your microcontroller. So if you connected the LED to pin 2, and then you bring your comma, right, just as you wrote here. So you say pin number, and then you write duration here, right? Yeah, and you put pin number here, pin 2, and then what is the duration? So you want it to last for, let's say, 1 second, right? 1 second is 1,000 milliseconds. So you just put the number there, 1,000, and that's it. So simple. And then now, whenever the setup part is running, it's going to call this action. This action is going to run. No, this function here is going to be this function here is going to work for yeah, it's just going to work. So here we call the function so that it works, right? Yeah, so that's it. We call the function so that it works. So this is it. This is it. So simple, right? But there can be a little bit of a confusion if you've not created a function before, if you've not studied function before, and that has to do with the name here. The name here. That does it always have to do you always have to write something like pin number, or do you always have to write something like duration? No. The words that you can put in here, it just depends on you, right? You can put any number in here, and those parameters that you put in here, you're supposed to you're supposed to put those parameters that you put in here. You're supposed to use those same words in the functions actions that you want it to perform in here, right? But yeah, this particular first one, it's going to sound something. But when we take a look at the return type kind of function, you're going to understand this. Do not worry. All right. So this we have created a function. We are saying this function is going to be a void function, but it's not going to be returning anything to us. It's just going to be empty. All right. So we write the name of our function, turn on and off. Our function is called turn on and off function. All right. And then we say it's going to be asking the user for just two parameters. So it's just going to be asking the user for pin number, and then it's just going to be asking the user for the duration. Good. And so after writing pin number and duration, we write the actions we want to perform in here. We say digital write, pin number, high, we're turning it on. So whatever pin number that a user types in here, that is going to be in action. So if a user types in pin 2 here, right, now it's like we've created a variable called pin number here, and that is going to be 2, right? And that is going to be 2 is going to be coming in here. 2 is going to be coming in here in a function. All right. And then we said a duration of 1,000 milliseconds. So for a duration of 1,000 milliseconds, writing that in a parameter here, the first parameter is the pin number. Second parameter is the duration. So after writing the duration here, 1,000 milliseconds, it's going to be the 1,000 is just going to be in this function. It's just going to be in something like a variable called duration, and that's going to be running, making sure that the function does what it has been designed to do. All right, so that's it. Now we can go into Tinkercad, and then we can see how it works. But yeah, let's take a look at now a function that is going to return a feedback, right? A function that is going to be returning a feedback. Yeah, so now let's create a function that is going to be returning a feedback. Let's create that. So yeah, we can create that outside here, also here. So all we have to do is just write the return type of this particular function. Since this particular function is going to be giving us a feedback, if the function is going to be giving us a feedback in a form of a number, so we use, it's just like creating a variable. Whenever you're creating a container, you need to tell whether the container is going to be storing a number, whether it's going to be storing alphabets, whether it's going to be storing, words, strings, right? Whether it's going to be storing decimal numbers or those things, right? So all you have to do is just tell the type of data that is going to be returned by the function, right? So you're creating a function and it's going to be returning, to you an integer. All you have to do is just write int, right? And then you write the name of the function in there. So you say int add numbers, right? We create a function called int add numbers, and then we bring our bracket open, bracket close, right? That's how we create a function. All right. So say int add numbers. So this is the return type of our function. This is the kind of data that is going to be returned by our function after it does all of the calculation. All right. So we say int add numbers. That's the name of our function, add numbers. And then in here, in the bracket open and bracket close, that's where we write the parameters. So let's see, it's going to be adding two numbers. So we have the first number. We're going to have the first number, right? The first number, comma, the second number, right? Great. And then those are the parameters that are going to be used in a function. Good. First number, and then the second number. So whenever someone wants to use our function that we are creating, all they have to do is just type in the first number here, and then they type in the second number there. So it's just like writing myself. Myself, my name is dash. I come from dash. So when someone is using that particular function, they have to put in their first number there, and they have to put their second number there. They have to put their own name there, and then they put their own hometown there. All right, and then we'll bring our curly bracket open and curly bracket close. And then now in here we have created our function. So in here we write what our function seeks to do, right? And this function, we seek to let this function add numbers. We want this function to add a first number and a second number whenever a user types it in, right? So let's write the code that is going to let do the addition, right? So all we have to do is just say first number, right? First number plus, right? First number plus second number, right? And then you bring a semicolon. But we know that this is just an action, right? This is just an action we are doing. So we need to create a variable to store. We need to create a variable to store this particular action of adding the first number and the second number. So we can create a variable called sum, right? We can create a variable called int sum, or int answer, right? Yeah, let's use int answer is equal to first number, right? Int answer is equal to first number plus second number. That's it. And then we write return answer. Return answer. That's it. So we have created a function here. We say the function is going to be returning a number. It's going to be returning an integer, positive and negative whole numbers, right? It's going to be returning an integer. Good. So if the function is going to return a float, if it's going to be returning a decimal number, all we have to just do is just write float, right? That's it. If the function is going to be returning, let's say, a byte, right? A number that is within a range of 0 to 255. All we have to do is just write byte. So it's like just creating. It's like creating a variable. It's like creating a container, right? So you have to tell which value or which type of data your function is going to be returning. If your function is going to be returning a number between 0 and 255, you can use the byte data type, right? Good. And then if your function is going to be returning a huge number, you can use the integer. Huge negative number, positive number, you can use integer, or you can use unsigned integer. If the answer is going to be in terms of a positive number, you can use the unsigned int, right? Unsigned int, and then that will be followed by the name of your function. But yeah, let's assume for our specific application here, for our specific function, wanted to calculate any number at all, right? Any number, any whole number at all. So we're going to be using the integer, right? So we say integer. That's the kind of data that this particular function is going to be returning. So that's the return type. So we say integer, and then the name of our function, add numbers, right? And then we'll put two parameters in here. So if you want to add three numbers, all you have to do, if you want to add three numbers, all you have to do is just bring another comma here, and then you write third number here. That's it. So simple. So every time users are supposed to type in a first number, second number, and a third number. So and also in the action that you are going to be running in the particular command that is in your function, you're going to say int answer is equal to first number plus second number plus 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 third plus third plus third number. It looks like someone unmuted. Do you have a question? Oh, all right. So plus third number. So that's it. So you do not, yeah, so that's it. That's it. Now you have created your function, and then you say, so this is what is this is the variable that is going to be storing the answer, right? So you say int answer is equal to first number plus second number plus third number, and then you say return answer. So you are telling the function that, hey, function, after you do the calculation, after you add the first number to the second number to the third number, we want you to give us a feedback. We want you to return the answer to us, right? So that's it. That's so simple. So this means that this function that we have created, the function called add numbers, it's going to give us a feedback with the value that has been stored in the variable answer, right? So that's it. So now after creating a function, if we want to call this function, if we want to use this function here, all we have to do is just go into our setup part or our loop part here, whichever we choose, wherever we choose to call the function, right? All we have to do is just write the name, write the name of our function here. So we say add numbers, right? Add numbers, and then we bring bracket open, bracket close. We go out and then we bring our semicolon, and then we come in here, and then we type in the parameters that we want to type in. So we can give our first number. Let's say we want to add 4, right? 5. Want to add 4 to, let's say, want to add 4 to 8, and to another number, let's say 15, right? Yeah, so that's it. So simple. So you just put 3 parameters in here. You put 1 parameter in here, put another parameter in here, and you put another parameter in here. So so yeah, that's it. And then that's it. That after doing that, you have called the function. You have called the function to start working, right? Yeah, and that's it. That's how we create a function, and that's how we let the function work. So first, we have a function that is not going to be giving us any return. That is not going to be giving us any feedback. It's not going to return any feedback to us, right? It's not going to give us any answer. It's like speaking to someone who cannot speak back to you, speaking to a dumb person, right? So when you speak to them, they hear it, but they cannot speak back to you, right? So that's it. So for that particular one, all you have to do is just say all you have to just say void, right? Meaning that this particular function, it's not going to be giving us any feedback. All right. It looks like I got a thumbs down, even though we didn't ask for reaction. Pius, do you are you good with what you're are you understanding this so far, or you have a question? Oh, all right. I I I believe that was I assume that was a mistake when you press the reaction. All right. So yeah, so that's the first kind. When you are creating a function that is just going to be doing an action for us, and will be returning no feedback, will be returning no answer to us, we just have to use the void, and then we say this function is going to be empty, right? It's just going to do an action. It's not going to be giving us any answer back. So we just write the name of our function, we bring our bracket open and bracket close, and then we put our parameters in here. So if we want to turn an LED on and off, an LED that has been connected to a pin number. So we just say the parameters that this function is going to be taken so that it can be able to work is it's going to require a user to type in their pin number, that's their name, right? And then the duration, where they come from or something, right? So this is just a template that we have created. And we can call the template at any point in time when we want the system to work. We can call it. After creating the turn on and off function, we can now call it here. And then we put in the parameters in here, right? So if we create a myself template here, we can now call it here, right? For Kingsley to use it, or for Michael Opoti to use it, or for Isaac to use it. And all they have to do is just type in their specific details, their name, their hometown, their favorite food, and all of those things. So that's it. So simple. And then we can create another function that is going to be returning a certain answer to us. So, for example, we can create a function in a system. What we have 5 sensors attached to it, and we want the system to calculate. Want the system to want to create a function that is going to be adding the first sensor's value to the second sensor's value, to the third sensor's value, to the fourth sensor's value, to the fifth sensor's value, and then give us the sum of the values, right? So all we have to do is just say, we'll just have to create a function by saying which type of data the function will communicate back to us or return back to us. If the function is going to be giving us a number like 1, 2 whole numbers, we can use the integer data type. So all we have to say int, and then we'll put the name of our function, add numbers, and then we'll put the parameters that our function is going to be taking. It's going to be taking the first number, second number, and then the third number. That's it. And then in here, the names that we have used here, the specific names that we have used here, we're going to be using it in here to write the actual command. So a command like int answer is equal to first number plus second number. So if you use if you create a parameter here, like let's say first, let's say for the first number you created a parameter like, let's say, use 1 st, right? No, we don't usually do something like that. So let's say you say number 1, yeah. So let's say number 1, right? So you say you create a parameter like number 1, number 2. So let's do that. You create a parameter like number 1, number 2, like number 2, and then you create another third parameter like number 3, like number 3. So number 3. You cannot, if you create a parameter in a function and you say number 1, number 2, number 3, you can't come in here and then you write something like first number, second number, third number. No, what you write in here, you're supposed to use those same words that you used in here in a parameter. You're supposed to use those same words in here when you're writing the specific command, right? So instead of saying first number, say number 1, right? So the user is going, so whatever the user is going to be typing first, the user types in 4. That number 4 is going to be the function is going to be understanding the 4 as the number 1 here, the first number, right? Good. And then the second number that the user will type in here, the function is going to say, okay, yeah, the user actually means that it's the number 2, right? And then the user types in 15, and then the function says, okay, yeah, the user means the third number. And then it takes those numbers as if these are variables, as if these are containers, right? So it will take those numbers that the user has typed in here, 485, 4815, and then it puts those numbers in the action here, and then it runs the calculation. So it adds 4 to 8 and then to 15. But the main thing we are taking a look at here is the specific words you use in here. You're supposed to use those same words in here. So if you write number 2, if you write the word number 2 here, you're supposed to use the same word. You're supposed to use number 2 instead of saying second number. So if you write number 3 here, you can't write third number because the word third number is different from the word number 3 because the spellings are different. This one starts with THIR. This one starts with NUMB, right? So yeah, you just have to take this off and then say number 3, number 3. Yeah, and then after doing that, yeah, whatever the user is going to type in here, the function is going to be assigning those numbers to these parameters here. So they are going to be acting just like variables, and then you do your calculation here, and then you store your calculation in a variable called answer. And then at the end, you can say return answer. It should return the value that has been stored in the variable called answer. So if a user says 4, 8, 15, what are we getting? What's 4 plus 8? 4 plus 8 is 12, right? And then 12 plus 15 is 27, right? So the answer we're going to be getting here is 27. So yeah, it says int answer is equal to number 1 plus number 2 plus number 3, and that's 27. So, and then you say return answer. So the number that is the results that is going to be stored in a variable here is 27. So now when we call our function here, when you call this particular function here, and we say add numbers 485, this particular function that we have called here, given it these parameters 4, 8, 15, it's going to be returning the value of answer, right? It's going to be given as the value of the variable answer. So it's going to return a value of 27 for us, right? That's it. So yeah, that's it. So simple. Yeah. So lastly, after calling the function in here, then you can say serial. Since the function is going to be returning a certain value of answer, you can say serial dot print, right? You can print the variable called answer, where the number the answer is going to be stored, where the 27 is going to be stored. And then you can now see the answer 27 written on your computer. The microcontroller is going to display that on your computer. And in our next session, you're going to appreciate this better. Before we are in tomorrow, God willing, tomorrow's session, but we're going to be taking a look at libraries. We're going to be seeing how these things work in Tinkercad, or otherwise we're going to be working with an actual microcontroller physically. So we're going to be going into camera, and you can see the you can see you can see that you can see me connect my microcontroller to my laptop or my computer, and then yeah, you see just how everything works. But yeah, this brings us to the end of today's session. We took a look at functions. We are built-in functions, built-in Arduino functions. It's like a company called Arduino or a platform called Arduino. They have come up with their own functions that they have created. Those functions can be used for math. They can be used for timing. They can be used for input-output stuff. Whenever you're building a project, whenever you're building a product for people to use, all you have to do is just go for the right type of built-in Arduino function, and then you can be able to use it. If you're going in your system, you're going to be doing math like square roots and all of those calculations. Even though you can create your own function to do those calculations, there's no need, because there's a built-in function for it. So you just have to go for it, go for the built-in function, and then you can use it. Otherwise, if you are creating a system where you want to create your own function, you want to create your own piece of template or your own piece of skeleton, right? That can be used multiple times in your code, right? If you want to turn an LED on and off, and you want to just write a certain function here, that all you have to do is, you do not have to keep writing lots of code in your code. You don't have to write lots of lines of code in your code. You just have to write just one function, and then whenever you want to turn an LED on and off, you just put the number here, right? You just call your function, and then you put the number where you have connected the LED to, and then the duration. That's it, and that's it. It's done, and it works. So the function that will not return any feedback, it turns things on and off. That's it. It does not return any value. It does not return any answer. And then we have function that is going to return an answer. So if you have sensors, 5 sensors or 3 sensors attached to your system, and you want to calculate all of those, you want to add those sensor values together as one, and then you print the answer on the screen. That sensor 1 was added to sensor 2, and it was added to sensor 3, and then in total, all of these sensors are giving us, let's say, 3,000, a value of 3,000. That's it. So you just have to create your function, put your parameters in here, and then now you can call your function in here, and then you see add numbers, and then after your function runs, you see a return answer. So after this, the function runs, it's going to return the answer. Yeah, and then you see serial.print. It should print the answer for you. After running this action, we know that code runs from the top to the bottom, right? So first come, first served. So if you write this first, that will be served before the second line. So after the function runs, it knows that it's going to be returning a value of answer, right? And then you can tell it, hey, print the answer on the screen for me to see. And then it prints the answer on your screen so that you see it. But yeah, this brings us to the end of today's session. We know our time is fast spent, but we're going to be getting into our practical sessions. And let's take this announcement. I believe everyone in here, we are approaching our time, right? Today marks your 23rd session, right? And then for your getting a very simplified introduction to robotics, right? For this simplified introduction to robotics program, 26 sessions were scheduled, and so we are only left with 3 sessions. From after today's session, we're only left with 3 sessions, and so we're getting to the end. But because you have to do some very practical stuff, You have to build your own project. You have to be able to use your components in your kit. There is going to be an additional 1 month. There's going to be an additional 1 month, and I believe most of you are on vacation. If you're on vacation, give me a thumbs up if you're on vacation. Give me a thumbs up if you're on vacation. Um, I believe you're on vacation. Give me a thumbs up if you're on vacation. I believe everyone in here, you're on vacation. So yeah, but the point is an additional 1 month, so that you make some very good progress building your own systems, building your own projects. There's going to be an additional 1 month where you're going to be ordering for your kit, right? You're going to be paying for your kit. It gets delivered to you with all of those resistors in there. You can build, you can actually Oh, all right. At UMAT, you're going to be starting exams tomorrow. Oh, all right. All right. Abdul Salam. All right. That's good. All right. All right. But yeah, that's the announcement. You're going to be getting an additional 1 month where you're going to be working on project with your kids, and then you're going to be designing a printer circuit board. You're going to send it. But yeah, there may be changes, and it's just going to be, those changes are going to be in such a way that it benefits you, right? So that you get the best out of your learning robotics, right? But yeah, our time is too our time has been fast spent. Let's bring today's session to a close. I believe everyone in here, you've made some good progress. Give me a thumbs up if you made some good progress. Give me a thumbs up if you made some good progress. All right, Abdul Salam, that's great. Isaac Herbert, all right. Akilo Puti, Herbert, all right, that's great. All right. Then on this note, everyone have a wonderful evening. Have a good night. We're going to be connecting. We're going to be connecting in tomorrow's session. All right. Bye, everyone. Bye. Bye.